Today we discuss the types of chemical reactions that can occur. We are learning this so that we can predict the products of any given chemical reaction, and our success criteria is being able to describe the four general non-carbon reactions. So these are the four generalized types of chemical reactions that exist. There are more types of chemical reactions than this. Chemical reactions can come in all types of varieties and combinations and permutations, but these are four of the most common and most general types of chemical reactions that we work with, and certainly the most common ones we see in high school: formation, decomposition, single replacement, and double replacement. In addition to being either endothermic or exothermic, these reactions obey particular types of patterns in their reactants and products. Any of these can be endothermic or exothermic, depending on the specific chemicals involved, but they always follow the same type of pattern. So, for example, a formation reaction occurs when you have two elements that react together to form a compound. We also call this sometimes a synthesis reaction because it's synthesizing a new compound. So in formation reaction, you have the elements coming together and becoming a compound. A decomposition reaction is exactly the reverse. You have a compound breaking down or decomposing into its component elements. A single replacement reaction occurs when you have an element, often a metal, reacting with an ionic compound, and the metals are trading places. Or if it's a nonmetal reacting, the nonmetals are trading places. So you end up with one element replacing another element in the compound, taking its place. So you end up with a new ionic compound and a new element. And then we also have double replacement reactions, where you have two ionic compounds reacting and the ions are trading places. So you end up splitting them apart into their component ions, swapping them, and then sticking them back together. And of note, with a double replacement reaction, what you'll see is that almost always these reactions occur with a precipitate. So you'll have two water-soluble ionic compounds that are reacting with each other, and one of the products created is not soluble in water. So it precipitates out and you're left with another ionic compound. There are a couple of small exceptions, like you can have an acid and a base react together in a double replacement reaction that we call a neutralization, and that produces liquid water instead of producing a solid. But for the most part, these double replacement reactions do create a solid precipitate.